Jai Hind everyone. I, Suvarna Mujumdar, welcomes you on a lecture on 8251 USART. USART is Universal Serial Asynchronous Receiver Transmitter. Before going to discuss about 8251 USART peripheral IC, just we will discuss about what is data communication and how this is useful in microprocessor. So data communication is nothing but when a computer is going to exchange data between other peripheral device or any other computer. So it can exchange the data, like it can exchange the data with the printer or scanner, which is situated near to your computer, that is within the remit of 5 to 10 feet. If it is like that, then we can go with a cable like connection, or we can have a parallel mode of communication. But when we want to communicate between two devices, two computers which are 1,000 miles apart and with a high speed communication, then we have to use some standard communication interface, or we can say some standard are given by the communication protocol, so that we can communicate between two computers or two devices parallelly or serially. So when we have to communicate with a parallel communication, then microprocessor is used parallel interfacing circuitry, and if it has to communicate in a serial mode, then we are using RS-232 standard, that is IEEE standard for communication. In case we are using data communication for serial communication, then universal synchronous or synchronous receiver transmitter, that is 8251 USART IC is used, which can convert a parallel data from a processor to a serial communication and vice versa. There are two types of serial data communication or synchronous communication, where we don't require to set a synchronous clock. We have to transmit between two devices. In that case, we have to set a baud rate. In case of synchronous communication, a dedicated line is used to travel the clock, so that both the devices can communicate at a same frequency. There are three types of transmission mode. Simplex, where there is only one sender and others are receiver. The example for this is our TV broadcast, where a station is there which broadcasts the data or the channels, and at our home we have a television system which will receive the data. So this is the simplex mode of communication. Half duplex mode of communication is an example with walkie-talkie, where at a time a sender will become a transmitter, and another time that sender will change through a switch. We can change that sender to a receiver mode. So at a time, one device will be acting as a sender and another device will be acting as a receiver. There is third mode of transmission, that is full duplex mode of transmission, in which both the ends are trans receiver, that they can simultaneously transmit as well as receive the data. And the best example is our mobile or our telephone system, where both the end can communicate simultaneously. So while communicating between these three modes of transmission, we have to choose any one, and mostly we are going with full duplex communication. So for communicating between two computers or one computer and other peripheral device, we use 8251A, that is Programmable Communication Interface IC. This USART, that is Universal Synchronous or Synchronous Receiver Transmitter, is a serial data communication. It is a 20-pin IC dual in-line package, and it uses for transmitting a data, that is from CPU. Parallel data is converted into serial data and it is transmitted on a channel, and then after receiving that serial data is converted again into parallel so that processor can process that data. So this is the pin diagram for our 8251. Here there is 8 data lines: A, D0, D1, D2, D3, D4, D5, D6, D7. These data lines are connected with the processor. Like in our case, it is 8085, which we are using to interface this 8251, or we can interface any processor or microcontroller with this 8251, so that it can communicate serially data. So this data bus is used so that we can configure this 8251 IC. Then we have receiver signal and grounded signal. We have transmitter channels ready. VCC plus 5 volt, we need clock, this RxD and TxDs are the line for data communication, transmitter pin and receiver pin. Then we have some control signal which can tell that whether transmitter buffer is empty, receiver is ready. Read signal and write signals are used for writing or data in this 8251 IC, or reading the data, that is the control word register if microprocessor wants to read. So read write signal are used by the processor to communicate with this 8251. And the most important signal is this chip select signal. So this chip select is that whenever microprocessor has to communicate with this IC, it has to first select this chip. If we have to restart this system, we have reset. So we will see one by one how this IC will functioning. So the block diagram of this 8251 USART consists of data bus buffer. So whenever microprocessor has to configure this IC, it has to write some data on this data bus buffer. Then this data bus buffer uses data for control word register. There are two control logics, one is read write and one is modem control. This read write control logic, this block is used so that microprocessor can configure this USART. And this modem control is used for modulation demodulation control, that is whether data set is ready, transmitter terminal is ready, receiver terminal is ready. So these are some control signals which are generated by this modem control when microprocessor has to communicate the data. So first microprocessor is to configure this 8251 using this read write logic. Then after configuration, whatever the data has to transmit, for example, it has to transmit some data. Then in that case, the data will be available with this data bus buffer, and then data bus buffer will send the data to the transmitter buffer. So the transmitter buffer from this transmitter buffer, the data will be sent serially on this TXD line. And this transmitter buffer is controlled by this transmit control. So we have some signals which can set whether this transmitter is ready or not. If it already has some data to be transmitted, then microprocessor has to wait till this transmitter control will be clear or something like that. And whenever microprocessor is receiving something data, this RxD signal receive the data, that data will be available with this receive buffer, and microprocessor can read this receive buffer. Once the microprocessor read this buffer, the buffer will be empty and indicate that the next data should be get inserted. So the total, we divided this 8251 into 5 sections: the data bus buffer, read write control logic, modem control, transmitter control and receiver control. So data bus buffer is the buffer where we have D0 to D7 line, and it can store the data like command word, status word and data which we have to transmit or receive. Next we have read write control logic, where we have 6 input signal, 3 buffer register, that is data register, control register and status register. And we have control logic that we can interface with microprocessor. So the function of this control logic is where we have a chip. So we can control using chip selection circuitry, these things. So chip selection, read write, clear and data, clock signal. So these are the control signals which are associated with read write logic. So chip select, whenever the signal is low, 8251 is activated and microprocessor is communicating with this IC. Control and data. There are two things. One, we have to configure the 8251 and then we have to send the data through transmitter line. Or once we configure the 8251, we have to receive the data. So there are two types of data. One is for control register and one is for data transmission. So when microprocessor is sending something as a control data, then this signal is active high. And when the microprocessor is sending data on this data bus line, then the signal is active low. So control and data lines. So when microprocessor is writing in a control register, the signal is high. When microprocessor is writing data on the data bus, then the signal is low. Write signal, whenever the signal is low, microprocessor is writing in the control register or sending data for output data buffer. When microprocessor has to read the status of 8251, then it will send this read signal, which is an active low signal, and it can read the data or accept the data from the data buffer. RST reset signal is used if we have to force this 8251 to restart again, or we have to idle mode case. Clock input is given so that microprocessor and this 8251 can communicate synchronously at the same frequency. Control word register. Here in 8251 we have a 16-bit control word register where we have two mode word and command word. So mode word is used where we can specify the baud rate, the parity bits and the number of bits, how much in a frame we can want to be associated. And command word will enable whether the data is transmitted or reception. So these register can be accessed as an output port when control data line is high. As I told you, C/D line, this line is high, indicating that control word is writing by the microprocessor. Status register. Whenever microprocessor has to see what is the status of this peripheral IC 8251, status register is reading by the microprocessor concerning the what is the status of transmitter buffer, what is the status of receiver buffer, whether it is empty or filled, whether data is transmitting serially or what. Then we have a data register. This register is used for input and output port. So the combination of chip selection, C/D line, and write signal and read signal, it will tell what microprocessor, which operation is microprocessor is going to be performed with 8251. So if chip selection is low, that this chip is selected, control signal is low, that is data lines is there, so and writing is high and reading is low. So what it means is microprocessor is reading from data buffer. So a data is available at 8251 and that data is read by microprocessor. Now again, if we have selected the chip, data line is 0 and write signal is low. It means microprocessor is writing data for transmitter purpose. In this case, in the second two case, microprocessor is writing something in the control register or status register, that is configuration. So whenever microprocessor has to configure 8251, this signal will be high, indicating that microprocessor is writing into a control register or reading from a status register. If this chip selection pin is high, indicating that this chip is not selected, microprocessor is not performing any task with 8251. So before performing any task with 8251, microprocessor has to make this chip selection logic 0. Then the third column in 8251 is modem control. So modem is nothing but modulation demodulation logic, where we have to first configure whether our data set is ready. So if data set is ready, then only the data get be transmitted. So this active low signal will indicate that data set is ready for communication, or we can say modem is ready for communicating the data. Then the DTR, that is data terminal ready, it indicates that device is ready to accept the data from 8251 for communicating with modem. So data is available from microprocessor to 8251 and from 8251 the data is transmitted on the data bus for serial communication, and that in that case data terminal signal will set whether this device is ready for accepting the data. Clear to send, if this is active low, then 8251 is enabled to transmit the data serially, bit by bit. Request to send the data, the signal is active low signal, indicate that modem is ready, receiver is ready to receive the data byte from the modem. So modem control, modem is another device which is interfaced with 8251. So whatever the data 8251 is giving to the modem, that data is transmitted from modem, and if modem receives some data, then that data is sent to the 8251. So the transmitter section, that is the fourth part of your 8251, from where the microprocessor, the data is sent as a parallel data, 8-bit data on a data bus buffer. This data is now stored in the transmitter buffer, and from there it is converted into serial data, and the TXD line is used to transmit data serially. Now buffer register will hold the 8-bit data and it convert the data into serial one and it is transmitted. So whenever the output register is empty, the contents of the buffer register are transmitted to the output register. The transmitter TXD transmit the data, and if clock we want synchronization, then the transmitter clock is there, TX C pin is there, which is an input signal which control the rate of transmission. And transmitter is ready, then TX-RDY signal will be active signal indicating that the buffer is empty and USART is ready to accept the net byte. So once data bus send the data from microprocessor to the transmitter buffer, TXD through TSD line, the data is transmitted. Once the data is, all the 8-bit is transmitted from TX line, transmitter ready signal will be active high, and this will come and as an interrupt to the 8051 or any other microprocessor. This interrupt will give an indication to the processor that the initial data which is given to the USART, it is already transmitted. Now it is USART is ready to accept the next data. Transmitter empty. If output signal is to indicate the register is empty and USART is accept the next data byte. Similarly, in the receiver section, whatever the data is received from RxD, it will stored in your receiver buffer, and there is two receiver input register and buffer register. So the receiver signal will receive the data and it will then goes low. The control logic assume that its start bit is there and it will sample the lines again and again that data is coming. 8-bit of data is received by the receiver at the rate of receiver clock. Then receiver ready output signal is high. It again shows that USART has a character in a buffer register and is ready to transfer it to the microprocessor. So when 8-bit of data is received by the receiver buffer of USART, it sends a control signal, or we can say interrupt signal, to the microprocessor that 8251 is ready with the data. You can read the data. So received data input, bits are received serially on this line and it is converted to parallel byte by the receiver input register. And if we need a synchronization, that clock circuit is there, clock signal is there. So receiver clock has an input which can control the data rate. This is the mode selection instruction format. So whenever we have to configure our 8251, we have to give the data, like if we have to create a frame. In a frame, how many bit of data we want to be stored, whether we want to store 5-bit data, 6-bit, 7-bit or 8-bit. For character length selection, L1 and L2, the bit of D2 and D3 of your modes instruction format is used. So if I have to select 8-bit data in my frame, then in that case, this bit, both the bits will be 1, 1. Now the baud rate, at what baud rate we want to transmit our data. So if we want synchronous mode of communication, then we use 0, 0 here. If we want 16 cross asynchronous, then 1, 0. Then if parity is enable or disable, if we make it 1, then we make it that parity concept is there for error detection and correction. And which type of parity, odd parity or even parity. So if we select even parity, we make it 1. And how many stop bit to be added. So if we have to add 2 stop bit, then in that case we make this configuration 1, 1. So it will be F, the instruction format will be F to L, that is A, B, C. So this will be our data which we have to configure, which we use to write in our 8251 control word register, so that we can configure our 8251 in a bit pattern of synchronous mode, parity, even parity, 2-bit as a stop bit, and 8-bit of data in a frame. Command word register. So this is again a register where we can have instruction to be said whether microprocessor will read the status, what is the status of 8251. Okay, so first bit, if it is 1, then we have a synchronous character, EN is 1. Internal reset high, that forces 8251 to mode instruction format. Then if request to send, if it is 1, then it asks microprocessor to send some data. Then ER, that is reset error flag. This flag is 1 indicating that there is an error with the communication. Then we have a send break character. So it will send a transmitter 1 if we forced, otherwise the normal operation is going on. If receiver is ready to receive the signal, we make it enable 1. If we want receiver to be disabled, then we make it 0. Data terminal is ready. So if this pin is 1, then data terminal is ready, otherwise 0. And if we disable the transmitter, then this pin is not active. So these are the command instruction format. Again, we have to activate this signal before using the 8251. Status information. So here from this register, microprocessor is going to read the status of 8251 at any point of time when it is communicating with other device and before getting any signal to be another data to be transmitted. So from this status information register, microprocessor can read the current status of 8251. Now we can recap whatever we have studied till now about 8251 USART IC. So we can recap whatever we have discussed about 8251 USART IC. So when 8085 or any other microprocessor, any microprocessor is a parallel processing device. So when it has to communicate with other peripheral device, it has to get interfaced with one or more standard signal. So we can interface it with 8251 USART for serial communication. Why we use USART? Because we use that data to be transmitted over long distance. If we have to communicate between a small distance at a length of 5 feet or 10 feet, then in that case, we can prefer a parallel communication and we can have a cable of 8 wires and we can communicate. But for high speed and for long distance communication, we have to convert parallel data into serial one. So 8085 is a parallel processing device. So it will give we as a 8-bit data as an output data and we want to communicate this data. So USART is used universal synchronous or asynchronous receiver transmitter IC, that is peripheral IC. It is used to convert this 8-bit data into a serial data, that is it will transmit a serial data, and whatever data is received, again it will receive a data serially and it convert this data into an 8-bit data. So microprocessor has to first configure this 8251. So first of all it has to select this using chip select logic. Then it has to configure this 8251. So 8251 has some command word, control word register and status registers. So microprocessor first have to configure this 8251, whether microprocessor has to communicate synchronously or asynchronously with a baud rate, how many data has to be transferred. All these information has to be written on this command word and we have to configure this 8251. Once 8251 is configured by 8085 or any other microprocessor, then the data, this 8251 is ready for communication. After configuration, 8085, we take as an example, it can send a 8-bit data on data bus buffer, on the data bus line, and these data is reached to 8251. Same data line is used for configuration also. So we need another signal. The signal is C/D bar. This signal is when we send control, that is command word, the signal will be high. This signal will be low, indicating that data is going to be transmitted. So initially this control C/D signal, control/data signal is high. Command word is written by the microprocessor, and after command word is written by the microprocessor, 8251 is configured, this signal will be low and now the data will be transferred on the data bus buffer. Once the data is reached to the 8251 USART, 8251 has a transmitter block. This block will convert this 8-bit parallel data into serial data and it will transmit the data through TXT line. Once the data is transmitted, microprocessor get a signal called transmitter is empty and it is ready to receive another data. Microprocessor will send another data through the line and again a second byte of data is transmitted. So on this process is going on. Once microprocessor has to receive something in the receiver mode, whatever the data is received by RxD, this data is received at the receiver block. Serially the data is received. This serial data is then converted into parallel data by this receiver block, and once 8-bit of data is received serially through a clock signal, both the activities are done through a clock signal. So synchronization must be there. So once the 8-bit data is received by the receiver block, again a signal is generated indicating that receiver is ready with the data. Microprocessor has to send some signal and receive this data. Once microprocessor read this data, this block will be empty and next data is ready for receiving. So in this way, USART will be working, and 8085 will communicate serially over a long distance. The same operation we can perform with 8086. The connection will be changed, some programming instruction will be changed, but overall hardware will remain same, and 8251 is used as a peripheral IC either with microprocessor as well as it will be used with a microcontroller also. So if 8251 we want to communicate through 8051 microcontroller, then again we can use USART. But in case of 8051, that is microcontroller, we have internal serial port communication. So whatever we study in 8251 right till now, this is already available with internal structure of 8051. So externally to connect 8251 is again a complex circuitry requirement. So instead of that, we have serial port communication in 8051, where we can transmit or receive data serially through port 3, pin number 0 and pin number 1. So in case microcontroller, we have that inbuilt USART in 8051. So this is all about 8251 USART IC. Thank you.